This is the first part of the electrophilic addition on alkene. We're going to look at the mechanism for hydrobromination of an alkene. We'll start with isobutylene that will react with hydrobromic acid in a solvent that is not participating. And we're going to look at the product, which will mostly be major product, the 2-methyl propane. So first step is the reaction of the alkene with the hydrobromic acid. The hydrobromic acid is a proton and a bromide. The alkene is electron rich, will therefore react with the proton. So electron will go from the alkene to the proton. This can form two possible products. First product, addition of the hydrogen upon the first step on the most substituted carbon. This will generate this intermediate. So attachment of the hydrogen, the two electrons are used to make a carbon-hydrogen bond. This will result in a carbocation, formation of the positive charge on the least substituted carbon, on a primary carbon. We'll see that very soon. The other possibility is the attachment of the hydrogen on the other side of the alkene. That will generate a different intermediate with the hydrogen attached at this position, forming now a carbocation on the most substituted carbon. So I've already used the terminology. You should in principle be familiar with that. So the carbocation form here is a tertiary carbocation, and the carbocation form in the first step is a primary carbocation. In terms of stability, the tertiary carbocation with 3 electron donating group is a lot more stable than the primary carbocation with only 1 electron donating group. So we can therefore indicate that like this. Tertiary carbocation more stable than primary carbocation, and therefore the primary carbocation is very unlikely to be formed. And we can exclude that from the mechanism. It's good to show all intermediate, but that's going to be a minor intermediate. Okay? Then the second step, the carbocation form can react with the bromide. So I'll redraw the bromide that can react. Add on the carbocation. As usual in mechanism, we show the electron movements. It's the electron of the bromide that are attacking the carbocation, forming reversibly the final product. This selectivity in the formation of one product over another one that would be derived from the minor intermediate is referred to as regioselectivity. And that's a key theme in this mechanism for hydrobromination of an alkene.